So this is the first video for step 5, and when you open the Excel tool, the first tab that you will need is the one that's labeled Stats. And in the tab there is provision for the entry of 50 data points. If you need more, you can enter more. In this example, I've entered, I think, 12, just to give you some illustration as to how the thing works. To establish a reliable mean and standard deviation, you'd like to get close to 30 data points, but more than 30 is diminishing returns. So you'd certainly want more than 10, 20, 25 would be good, 30 would be ideal. Don't waste any more time and effort getting a higher number, because it won't get you any further. When you scroll down at the bottom of this, it tells you that the mean or the average for those few numbers I put in is 14.5. The standard deviation, which is the width that the numbers are from the mean, is 2.8 units, and therefore the width of the distribution curve is 3 times 2.8, either side of the mean. And it also tells you that 68% of the population that we're sampling from will fall between 11.7 to 17.3 units. 95% of the population will fall between 8.9 and 20.1 units, and that it's quite likely that the population will, and therefore the width of the curve, 3 standard deviations either side of the mean, is 6.2 units at the low end and 22.8 units at the high end. The median is the middle of the data set. So if we laid out all the numbers that we've collected in either ascending or descending order, the middle of that data set would be 14 units. And the difference between the mean and the median is half a unit, 0.5 units. Now the mean is very sensitive to extreme values, whereas the median isn't. So if I do something like I'll add a number of 100, and you will see now that the difference between the mean and the median has, just by adding that one number, has gone from 0.5 to 7 units. So if the data is not normally distributed, then we would focus on the median, the middle of the data set. So where is it centered? We would use the median. And how wide is it? We would use the range, which would be the maximum number minus the minimum number, as opposed to 3 standard deviations. Now, I'm just going to add another couple of numbers in here. I'll add 110, 105, 99, and 101. And off here to the right is a time series chart. So it is a chart of the readings in the order in which they occurred. So we would use this to look for patterns and trends. And what you see here is that we had the original numbers, and then I added the value of 100 and so on. And this is showing you that there's actually been some sort of shift. So we can see that something has occurred, and the something that occurred was me entering data. So we get rid of those, and the chart is adjusted, and we just see a chart of the 12 data points. It appears to be random. It's going up and down. There's a bit of a spike here at 21, but we don't have enough data to know whether we should be concerned about that. As a rule, 5 points in a row, 5 or more points in a row going up or down would be indicative of a trend. So we now know where our process is centered by either looking at the mean or the median, and we know the process width either by the calculation of 3 standard deviations either side of the mean, or we know our observed range. On the next tab, we have process capability, which is the relationship of the process distribution compared to the specification. So there are some green shaded cells here for you to enter your information in here. This first block is process capability using the mean and standard deviation. Enter at least one specification limit and any desired target. You don't have to have a target. And I've chosen 6, 14 and 21 units. And this is telling me that my expected process location and width, the low end of the distribution curve will be 6.16 units, so I'm just within spec. My process is centered at 14.5, I'd like it at 14, and my expected upper width of the curve is 22.84 units compared with 21 units. So we do have some defects here. So we have the difference in the target. The specification width is 15 units. My process width is 16.6 units. So my fit is 0.9. So in other words, 90% of my process fits within the specification, but I have 10% of it that doesn't. If we're dealing with time series data and non-normal data, and we're looking at the median, again, we put in our lower spec, our target, and our upper spec, and we have a median, observed median of 14 units here. The lower end of the range is at 10 units, and the upper end of the range is at 21. So we're actually fitting our ratio, the process width will fit within the specification width 1.36 times. So we're generally good. We're a little bit close at the high end. There's not a lot of wiggle room there, but we generally have a reasonable process here.